Hello, we are back live. Happy 4th. Got a lot of stuff I want to do today. Let me show that off real quick. Show the plan. You have a thematically appropriate project for today. Involves drones. Arca. Huh? Let's see. Welcome, Ajid. Today we're gonna make the drone swarm thing actually work, and we're gonna do something thematically appropriate for the 4th with it. Talk. I will probably be doing the article tomorrow for most of the day. I might work on it a little bit after this, but this is appropriate for the 4th. So I would like to have this done for the 4th. We're gonna see if we can make the drones assemble themselves into the American flag. It's gonna be cool. I figure that'll be a cool demo that'll get some people interested in Puffer, yeah? And I actually have to go look at my own flag for cool marketing idea, yeah. I have to do a little bit of stuff like that, right? It's fun, it gets companies interested. Going to be blue, blue, blue. Red, 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 red. Half the flag. It's tough to do like a downsampled American flag. Stripe is red. Our flag's kind of complicated, all right? It's not like the China flag or the Japan flag where it's super easy to know what the heck it is. Got the stars for the states, and that's like the stripes or the colonies or whatever the heck, but like I don't think most people actually remember the order or how many are in each row or whatever. No, we like our flag. Morning, Brian. My name is Joseph. I've been thinking about renaming the channel. You kind of confuse everybody when you rebrand it. The channel should probably just be my name or whatever, because it's all of my stuff across a bunch of different projects. But like my handle does not make a good YouTube thing, because my handle's J Suarez 5341. It looks like autogender, whatever. Okay, so we do the position. Uh, oh, we can literally just do it like this, actually. This is super easy. We'll just turn the plain task into the flag task, because it's basically the same thing if you think about it. We'll just change this into flag. We have the reference flag, of course. The aspect ratio of the flag, it's like 3-to-1, isn't it? It's like 3. Can't do 3 times this. I have to do 2/3. Do like something like this. This actually shouldn't take this like that long. I might even be able to just start working on the article today. I do want to make sure that this is actually good, though. Initializer element is not constant. Why? Yeah, this is not gonna work with this pound define, right? Why is that an error? Okay, constancy. I gotta actually do reading up on why the heck that happens. Oh, and we are. Okay, so if this flips the axis correctly, then all we'll have to do is change the drone colors, and we should get a nice flag effect. We'll just have to train a slightly better policy. Cool thing about these is I shouldn't even have to really retrain. Handle with nums. Oh. It also kind of looks auto-gen, I don't know. My handle is that because I can get it everywhere, right? You can never actually get your handle, so it's like, if you don't just pick some random number these days or have some incredibly specific username that's not actually based on your name, you won't get the same one everywhere. So like my Twitch is the same, you know, my X is the same, Discord, like they're all the same. Like the thing is that the solution to this is to have people have like the extra, you know, like the extra numbers that if you hover over you see. But that doesn't work super well for social media stuff because it's really easy to impersonate people that way. So okay. So here are our drones in a sphere. See, that's what they're trying to do. They have the follow task, the idle task, the hover task, orbit, follow, line. Okay, so here's the flag as it's supposed to be. It's not terrible. It is on the wrong axis, though, I believe. Yeah. So should it be YZ or something? Try this. Yeah, so that's a good flag. Now all we have to do is actually set the drone colors. Okay. Okay, so here are our drones. Flag is upside down, I can tell, right? Oh, this is gonna be super cool when it works, though, I can tell. See if I can just flip it upside down. Okay, so I think we have to re-estimate like collisions or something here, right? So the body sphere is radius. Wait, is that the radius? I think that is the radius. Go to our raylib docs here. Why is restream not showing? Okay, stream is fine. This is the radius, yes? So the body has a radius of 0.3. And then the rotor has an additional 0.15. That's going to be times 2. So this is, it should be size 0.6. Is that true? How big are these targets in comparison to the drones? Oh yeah, no, that's right. Because if those are 0.25, so yeah, this has got to be, if we do 0.45 for the target, this will be the size of the sphere. If the flag was moving in a circle, it would be easier for them to do it. We'll train a better policy, Tim, don't worry. I want to make sure we get it so that it will look good when we have the policy. And then, leave the RL to me. I can always get RL to work. Okay, so is this the size of a drone? Yeah, that's about the size of a drone, right? So this is a radius of 0.45. So it's actually drones are colliding if they're basically within 1 unit of another drone is going to be collision. So I didn't think about that at all. So let's see what happens when I retrain with this dramatically larger collision penalty. Welcome, YouTube folks. For the people who got here recently, I'm currently, since it is the 4th of July, happy 4th, we're training some drones to make a flag in midair with reinforcement learning. This will be a good environment for us to use in research. It will be a cool demo for people in industry, and I think it'll just be a fun thing overall. Okay, so this is noticeably smaller reward. I think we were getting up to like 454 before. So this is essentially telling us that the task is harder now. And the fact that it's actually still learning, though, is good. Ah, it's actually, yeah, that's pretty good. Let's go check all the rewards. I'm sure at least some of these I've just defined stupidly. Happy 4th, Brian. I'll update these rewards next. May the 4th be better one. That's May 5th, not July 4th. Okay, so this is them attempting to form a sphere. This is them attempting to follow random targets. We should put in a collision tracking term now, because they're like not as close to their targets anymore, but it seems like they're way better at not colliding, which is roughly what we'd expect. Like, look, they're all following, right? They're all following this target. but they're doing it in a way where they're trying to not collide. Fine. Yeah, they do all form their line, yeah. But see, this line is like, it's too close, so they can't actually do it. So that's going to hurt training quite a bit. Okay, so let's fix up some of those tasks. Mesmerizing, it'll be a lot more mesmerizing once they actually work nicely, you will see. Patterns are nice, yeah. They should be cool. Oh yeah, that's our in. Welcome. I'm learning. Slowly. Trying to think what we do about this line task. You have to be kind of careful in reinforcement learning, because when you give stuff impossible tasks, like you can kind of mess up the rewards. Okay, I think we're gonna do, instead of line, we'll do cube. How bad is it gonna be to do a cube? Kind of have to, right? This is the only one that's messed up, because there's just not enough space. There's no good way to generate that formula, right? You just kind of have to like write the whole thing out annoyingly. Wait, how many? A cube has, is it 12 lines for a cube? 4, 4, and 4. Yeah, it's 12. Anything else I can do that's like has an easier mathematical formula? Or not really? Maybe there's like a sampling based one. No, this is something else. Sample. Oh, we could just do cube instead. That would be way easier, right? 4 by 4 by 4 is 64, right? Yeah, so we can just do that. That's super easy. I was thinking of like the outline of a cube, but this is so much easier. Hey, Brad. Doing pretty well. Pretty well. Okay, that's not a cube. IDX percent 4. Okay, so it can't be divided by 4. Okay, so now since it's 4, we can do 4 units. 4 times x, 8. Okay, almost. Almost a cube. Okay, that's a cube. It's just offset weird. What do you think is the biggest challenge in getting RL agents to generalize to different environments? Should I do a little segment on this? I do have a clipping thing that maybe will let me put this on YouTube if I explain this real quick. This is a pet peeve of mine. Okay. Yeah. This is a pet peeve of mine that people say, oh, reinforcement learning doesn't generalize. It doesn't even require you to know anything about reinforcement learning to understand the problem here. I don't know. People have these magical blinders when it comes to RL. So let me give you the analog, right, of what this looks like in supervised learning. So let's say that you train an image model on like cat, and then you say, well, can we use the same model now that can detect cats to detect dogs? And if you ask anybody in supervised learning, at least with traditional methods, no, this does not work. This is not how we train models. This type of generalization doesn't work at all because something that has only ever seen cats is not going to be able to recognize a distinct, equally complex topic. This is like asking you to study mathematics, okay? And now because you know mathematics, you should be able to like zero shot know chemistry or some other subject. So how do you actually make this work? Well, you don't just train on cat, right? You train on like cat, snake, chair, computer, and then you have a whole bunch of new topics, okay? And then the representation that you learn from all of these maybe lets you learn an equally difficult concept, right? This kind of works. So what does this look like in reinforcement learning? Okay, train on Pong, breakout, literally the same problem. So if you were to train on a ton of different environments, right, like Tetris, and if you were to train on hundreds of these, then yeah, you can actually potentially get some transfer. It just turns out, one, we don't have a ton of environments, and two, there's some annoying infrastructure challenges that make it slightly more difficult than just putting different images into the same model. But yes, generalization does work in reinforcement learning. We have very many instances demonstrating that, like, if we generate a whole bunch of tasks, we can solve new tasks never seen of the same type. You just kind of have to think about it in terms of this parallel. So there you go. Let me grab a cup of coffee, and I will answer any questions on that. That makes sense, Brad? Hey, Major. Welcome back from my 30-second coffee, refill my coffee break. That is fair. Perhaps it's not the right question. It isn't the right question to ask, but the thing is, you're not the first one to ask it that way. And this is one of the things that drives me crazy in reinforcement learning all the time, is you have RL researchers, right, who will basically just say, oh, RL is bad because it can't generalize from one environment to another. I will go spend 2 years working on this problem. You don't need to spend 2 years working on this problem to look at it and do the exact thing I just did and say you will fail, because that's just not a thing that even makes sense. Like, there's no reason to even suppose that that's possible. But it doesn't matter that it's not possible, right? If we just keep making our methods better, And eventually we scale the stuff and figure out there are like a few infrastructure problems making it a little annoying to scale to more tasks. It has been done, it just hasn't been done at like very small scale. I've been meaning to do this soon because I actually have very, very convincing evidence that RL generalizes from like my various experiments I've run. It's just at smaller scale. But yeah, like RL kind of does this all the time where they fail to draw parallels to other areas of ML where these questions have been answered, and instead they spend a lot of time trying to solve problems that are pretty clearly not solvable. Right? And actually, Brad, let me just show you how bad this is. So I interned at OpenAI when I was like 20, maybe 21 at the time. If they had offered me a full-time position, it would have been to work on this paper. Okay, this is hide and seek. So in this paper, one of the things that they wanted to do was they wanted to ask, can we train these agents to play this game and then have these same agents transfer to other tasks in the same environment, mind you. So doing other tasks in the same environment. It was stuff like, can we have them count objects in this environment? Can we train them to like move the things to a specific place? And before they even started writing a single line of code on this project, I told them that it was doomed to fail. And I basically made the exact same argument. This was 2018, 2019. I made the exact same argument that I gave to them, which is, hey, look, if you want this to work, you're going to have to train the agent on a whole bunch of different tasks, and then give them some tasks that are new, that are of the same complexity, or ideally a little bit easier. And then it'll work, right? If you train on at least several hundred tasks, maybe more, and then you give them tasks that are specified with, the same sort of format, that are maybe even a little easier, then it'll work. They didn't listen to me. They wanted to just try it anyways. And what happened? The exact thing that I told them would happen. Basically, in most of these tasks, it makes almost no difference whether they pre-train it or train it from scratch. Doesn't help. Sometimes you get lucky and one of the tasks ends up being pretty similar, but for the most part, doesn't work. So the question that you asked was not necessarily a stupid question in the sense that this is a project, right, where world-class RL researchers spent over a year on this. I think it was close to 2. Now, mind you, I had the answer correct from the start, but this tends to be one of those things that I'm pretty good at. Is like coming up with those really basic, obvious arguments that don't even require you to understand anything about the field to like see why something makes sense or doesn't make sense. For some reason, in RL especially, like that type of thing is just very rare. And that's why pufferlib is allowed to exist. Because in a sane field where people do things a sane way, I would not be able to make something that is 1,000 times faster than everything else. And I wrote this in the article, this is a definitely top 10 result in reinforcement learning. At one point, it was a top 5 result. I don't know if it's a top 5 result anymore. It's probably still just a top 10 result in reinforcement learning. I actually personally think that our latest result on neural MMO is better than this. Like, holistically, as far as a RL result goes, I think this is a better result than emergent tool use. This thing actually does emergently use tools as well, right? Takes it, and it doesn't even like, it has to actually go figure out where the tools are. Here, it's trying to figure out how it can get that one. What are the top 5? For me, the top one by a mile is OpenAI 5. It's Dota. I love that project. Like, you can basically learn almost everything you need to know about reinforcement learning and how the field will be solved. And actually, a lot of what I've done for Puffer from just that one paper. Alpha Star, I would put as a somewhat close second. I would put Go in there. I think I put Go number 3, but keep in mind I could just not be respecting the difficulty of Go enough. The thing that makes StarCraft and Dota better for me is like they require a lot of different types of reasoning that are really kind of obvious, and it's a heck of a lot easier to play a bit of Dota or play a little bit of StarCraft and kind of understand why the game is hard than to play like a bit of Go. You kind of just won't understand anything for a very long time. The number 3 and the number 4 slots get harder. So for quite a while back in that era, it was capture the flag and emergent tool use were my number 4 and number 5. Now since then, there's been stuff like DeepMind did Xland, and there have been like some other results and not like just not straight RL research, but applications of it that have been pretty good. And by the way, when I'm saying top 5, I'm talking about like large-scale results of solving a problem with RL in a way that tells us something about RL itself, right? So obviously, like the original stuff, like PPO, the algorithms, I'm not considering those in that same class. But in terms of like the impressive results that change the way you think about what RL can do, it might even still be those. I probably put Xland. Where do I put Xland? Gotta be like number 3 or 4 after those. But I don't know. Since then, you know, we have 2 results in Puffer that I think are up there now. Solving Pokemon, well, not solving, but beating Pokemon Red with reinforcement learning. Crazy result. Not quite as clean as I would have liked it to have been. Mainly just because the end was slow. But yeah, Pokemon Red. And then now we have Neural MMO 3. These are our 2, what I would say are our 2 big results. Don't discount the Puffer. I haven't watched the presentation, Brad, but if you're talking about the one that's like watching the Atari and then like having a robot like play the thing, it's not the direction I think is going to like be the useful one for RL at all. It's cool work, and John Carmack is amazing, but as far as the direction that line of inquiry goes, I've seen it, and it's not the direction I think that we need to go to make this field actually work. And to follow up and answer that, what does it mean for RL to be solved? Well, it means a lot of things. I would say that we have fixed reinforcement learning in the last year. We have not solved it. And by fixed, I mean that if 1 year ago you were to try to do literally anything in reinforcement learning, it's slow, it's janky, it doesn't make sense, and there's not a single person in the world that can reliably predict the outcome of almost any experiment. It's just a complete black magic mess. Now, we're at the point where we can run stuff fast, we can mostly predict the outcome of what's going to happen, and we have automated tools for handling a lot of the unintuitive bits. Now, I think RL can learn way faster. I think that there are lots of edge case problems where it's not very good, where it could be good, right? Sample efficiency still needs to be tackled, but in a very different way than it's been approached ever. Generalizability, same thing, but needs to be approached in a different way than it's been approached ever. Lots of different problems. Solved would be, in my sense, like becoming a mature area where the only progress that is made is incremental. Basically, the field gets saturated to a point where it's like it works very well, and you can really only make incremental progress on it no matter what you do. I have no idea what you're talking about, though. Oh, hey, that guy's the one that did Pokemon Red. Is the main, the lead on that. We were just talking about that as they were asking for the top 5 results in reinforcement learning, and I think Pokemon gets a slot in there now. Will RL be applicable to everything? No. Not uniquely applicable to everything, let's say. You do actually need generative models for language and vision and areas where you just have a ton of data and you need to compress it, pretty much. Supervised learning problems. Like, you're not going to learn NLP from scratch with RL. It's just a very inefficient way to do that. But similarly, I don't think you're solving everything with LLMs either, because the priors that you get from understanding vision and understanding language do not help you solve fiddly, unintuitive optimization problems where our tiny models are superhuman. I've been so busy, I haven't touched Puffer 3 in a couple of weeks. Puffer 3 is very good. Trying to spend 30 minutes to track down why there was an obspace violation in the new version. Obspace. Did you send me a link or an issue on that I ignored or didn't see? I also got super busy with the release stuff. But yeah, that guy. We're doing drone swarms today. We're training drones to like hit a bunch of different targets in different shapes. Dinky and I ran into it, so we disabled the obspace checks temporarily. I mean, you can do that, yeah. If you send me a repro, I will. I'll look into it for sure. And since we have a fair few folks here, as usually happens when I'm yakking out stuff a whole bunch, it's all open source stuff, all open source RL, call it puffer.ai, start the repo to help us out, Discord to get involved with dev. What we're doing at the moment is we are training a bunch of drones to fly into various shapes, and because it's the 4th, we're going to include the American flag as a shape in there. Ah, there we go. Okay, so that's the cube shape. PR it for fix for torch.nan not being a tensor. So where are you getting nans? Because usually once you have nans in anything, it's kind of GG. And even if you don't make the thing crash, like, even if the program doesn't crash, which admittedly is nice for sweeps, you're still gonna like immediately crash all learning. It's in a debug setting I have. Debug. But like, can you explain what you're doing with the nans? Pufferl 442. I assume not here, right? Oh, is it nams on variance? Is this what it is? Oh yeah, you can PR that. I'll just merge that instantly. That's fine. I haven't looked at this in a while. That's fine. I can add that. Doesn't have an odd item. Yeah, you can PR that. That's fine. Or I mean, I can just like, what did you do? Did you just do like torch.tensor of it? Is it just like torch.tensor like this? Or honestly, we can just do torch.nan else dot item like this, probably. Since, oh yeah, we can just one line that, right? Like this. What you're doing is here is better. Yeah, this should be good. I hate adding little stupid checks everywhere when I can avoid it. Okay, let's make sure that the rest of these tasks are reasonably presented. I believe the only one that's still weird is the Congo task, because I think that they're too close together. Okay, this is good. Let's see if we can train this. So the hope here is that because we have more reasonable tasks, that this should be more stable. Actually, we can kind of check this a little bit. Okay, so here is episode length. We want perf or score. Either of these metrics is what we want. Probably score is better. So this is the score previously. We'll see if this makes any sort of difference. Goal is to get nice, stable, clean drone policies. And they should be able to form a sphere, form a cube, follow each other, follow one specific point without crashing for the most part. We should actually add a collision log in here as well. We have add log. Last collision, episode length, float. Float collisions. Set the agent. Okay, 428. This is our latest policy. Form a rough sphere. Could be better for sure, right? This is them just like fly around, don't collide. They like want to roughly track some spheres, but that's all. Flies, man. This is cool. Want to form a cube. Oh, it's definitely starting to get there. Tricky though. Go get the collision rate thing working real quick. I have to take a quick break to kill this fly in a second. It's driving me nuts. OOB rate. Okay, so we want collision and OOB. Knowing what you know about RL, do you anticipate the big LM labs will be able to harness it for huge intelligence leaps? Possibly yes. But the funny thing is they will be using a tiny, tiny fraction of what RL is actually capable of. They're kind of doing like ultra baby mode reinforcement learning. I mean, you're right that it's going to do a bunch of stuff. I just think that you're going to get a tiny, tiny fraction of what it can actually do. And your feedback loop for research is incredibly inefficient because the models are so damn big. results with 80 bill and 32 bill models. Yeah, those are still huge. And those are still like, the experiment loop is still incredibly, incredibly slow and expensive for stuff like that. Relative to 500 bill. I mean, the way I look at it, that's literally like one order of magnitude, right? One order of magnitude difference. We're doing stuff like, what, 5? No, 6? Or 6 orders of magnitude smaller, I believe. Sometimes 5. No, it's 4 or 5. I'm wrong. Okay. It's like massive difference. Okay, so we actually do see that we get slightly better performance now than before after we fix the tasks. But it's still not perfect. What about the collision rate? Okay, so collision rate goes down. Let's try a few things real quick. Let's see what our model looks like first. I tend to hope that the large results will work their way down to smaller models. Yeah, so I'm just doing it the other way, man, right? I'm like, alright, screw it. I'm just gonna do stuff at small scale and hope it scales up. Track various metrics. Oh yeah, it's very easy. You saw it, like, you saw how quickly I added all that stuff, right? You pretty much just add some stuff to the C and export it, and it just gets picked up automatically. There's some of the tools that we've built for this stuff, yeah. Congo line here. Interesting. I wonder to what extent what do you think with the test time compute? Test? You mean test time compute? I mean, I'm sure they're very happy about it because instead of them training a really, really big model, right, they're letting you pay exponentially more for results at test time. I mean, they introduced exponentially more expensive evaluation, right? Which is actually kind of funny because, like, hey, if you want to get results on this one specific task, you can spend more compute. What I do with a lot of my reinforcement learning stuff is, hey, if you want to get results on this one specific task, you can just train a model from scratch in seconds. Really skeptical whether they're the right path. I give them a 1 and 3. I think that they will be relevant and useful, but I don't think it's going to be the only thing we need. Yeah, it's the thing is that they need to hype everything because they need to get funding, and they need to get funding at like the scale of tens of billions. So like of course this is going to produce a really screwy setting, right, in which like people are making ridiculous claims about stuff and just lying right and left. And then the real researchers are like, "Ah, but we just want to do our research and we want to make the things work." And it's not a good setting. It's not really a good setting for anyone involved. We got to redo this cuz all over the place. Okay, so all I did is I made the horizon longer so that you actually can see the hope is that the drones will actually have time to figure out how to align themselves at the final bits of the task. Because I think what was happening is they're just getting like 80% of the way there and then they're running out of time. Because this article did really well. My best article by a mile. If you have not read this yet, I do recommend it. This and Pokemon are the two best results powered by Puffer. Like it too? All for the algorithm. Does that even do anything? I don't usually like my own posts. If I were designing the algorithm, I would just not, like, I would make that not do anything. I want my pat on the back button. I would weight it down for self-like. I'd probably do that as well. Okay, so here is Is it just me or are they like not, none of them are like perfectly on the target, right? Okay, this one they're not really expected to be. I noticed they're not they're not actually ever getting directly on the target. They should definitely be able to do that. If I do like the hover task or whatever, yeah, there's something wrong if they're not able to get directly to the target. Let me train just hover. They look like molecules. I mean, if you want to make some molecule sims, I'm just like, that's the thing I actually most want to do with Pufferlib. The thing I want to do the absolute most is like some sort of ridiculous low-level material sim that just like invents a ton of new materials and like, I don't know, discovers miracle drugs and all the things. So if you want to go start on that crazy mad scientist arc, solve the three-body problem with RL. Ow. You're learning. Well, actually, wait. You need a stable sim, right? I guess it's not that slow. I don't know. There are a lot of problems that you can probably get fast approximate solutions to, but the problem with that is like being approximate causes chaos. Is it even learnable? Like, yeah, but the thing is that it's a chaotic process, so like approximating that is not fun. Oh, it's not training on all the tasks. Eh, that would do it. Let's see what happens when we just train him to hover. If it's not exact, like if this doesn't exactly solve, then there's a problem because this is a really easy task. Incredibly stupid. Okay, so we're getting 98%. Almost no collisions. Perf nearly won. So if we eval this, the drone should just be hovering. You can see they are hovering. I actually still want to improve this a little bit because, like, they should all be exactly on target, and I don't know why they're not. Very easy problem. So they probably can't see why they're wrong. And probably if we fix this task, it'll fix all the other ones. The sensors are broken. This is why sims are amazing. Right? Simulation allows us to isolate the causes of error way, way, way better. It's like, even if you want your thing to work on hardware, you should train it in sim for the purpose of debugging and doing all this stuff. Even if you think that your thing needs to be able to train in not very many samples, you should train it fast with a whole bunch of samples so that you're actually able to make progress at a reasonable rate and then pare it down later. Use the restroom real quick and then we will fix this thing. Yeah, hardware is hard. That's why it's called hardware. Right back. Yeah. All right. So, the quest for why the drones don't exactly hit their targets begins now. The reward is based on Euclidean distance. So they're still going to get a small reward for this. It's a very small reward, but it is a reward. I'm more concerned about the observations. I bet you this is the issue, right? Like, what if instead of dividing, what if we do this? Clamp F. F. What if we do something like this, yeah? So the intuition here is that what happens if the delta observations are just getting too small to really be perceptible? On position. Okay, these can still be left alone. What if we do this? We will compare directly before and after. Okay, interesting so far. Should 1 be in the space box 0, 4, 1, uint 8? I think it has to be an array of dimension 1, and then the data type of 1 I might also have to be a uint 8. I also... I don't think we do uint 8 boxes either, that guy. Do we? No, you're right, we do. We do uint 8 boxes, I'm wrong. Yeah, no, we do that all the time, scratch that. Yeah, no, we do it as well, I'm wrong. Don't listen to that. NumPy array of 1. So NumPy array of 1 will give it a float 32. Or float 64, I believe, by default. Yeah, NumPy does, like, float 64 by default, I believe. We would have to check if something's erasing. Oh yeah, why are you passing it to Puffer like that, though? Because, like, that box... We do that for observation spaces, right? Which is the env passing to the trainer. We don't ever have uint 8s passing back, right? There's not really a reason to do that. For the ob space, yeah. So, but the ob space, the puffer gives you the observations. They should be in format of uint 8, and then you put them onto the GPU, and then you turn them into whatever D type you want, right? Okay, this looks a fair bit better, yeah? I don't know what this guy's doing, but most of these are, like, a bit better. D type equal numpy uint 8. When you say you're passing it to puffer, where are you passing it? Because you're not passing observations to step, right? What function are you passing it to? Where you think it's getting messed with? Check space is failing for some reason. Well, I mean, that's possible that it's like also possible that it was bugged in 1.0 and I fixed it since, right? Something between the step returning obs and check space checking. But check space checks it before step returns. Oh, you're end step returning the obs. Yeah, if you send me a repro, I will. I'll see if I can fix it for you. It's not like training crashes horribly when you comment the check space, so it's probably that it is like a bug somewhere with this thing. Made it to Friday. This like SPY's alt or something. 4th of July, man. Try to get time to get the fireworks ready. We think the reward magnitudes just get too small. Can I like clamp this? Okay, we clamp this thing. I see that there's a problem with this actually, but I'm gonna try this first. Diddy watching Pupper Park. I guess it never truly checked the dimensions of the input before. That is what that function is for. It is to make sure that the dimensions make sense. Interesting. This appears to break it completely. Oh no. Covers. Somewhat. Collision rate is very high. Somehow. Curious what the heck this is doing. But yeah, we're probably only a few small reward tweaks away from having this thing just working perfectly. And it's gonna like suddenly look way cooler than just the drone's hover when it does, because we'll be able to train it on all the tasks. And it'll basically just go from like sphere, cube, follow, flag, you know? You'll just get drone constellations. Okay, so this is not the intended result at all. Ah. What the heck is lagging my computer so much? Crazy, you have a top end screen and all the crap these days is like badly optimized. Okay, it's more stable at least already. Okay, so this also does not work anywhere near as well. Oh, the scale just changed. This actually works better. Yeah, there are way more of these directly on target. So... interesting. Well, but this is annoying because, like... no, I guess this is fine. This is basically just saying you have to be exactly on target. No, this is better. Okay, so... we probably have to fix this collisions thing. You get a negative distance reward and you collide, you get a positive reward, right? Okay, we'll try this. See if this is stable. Upgrade to Python 3.12. Endianness is flipped. Are you shitting me? Oh, you know what? Can you check NumPy? Because this was a thing I saw where, like, actually... there's some screwy thing with NumPy. Oh, in your code, not Puffer. Okay. So, are you saying that the Puffer is absolved of all wrongdoings? Is that what I'm hearing? That's what I'm hearing, that Puffer is just the best software ever. Absolved of all wrongdoings, and cures all the ailments of reinforcement learning. This is kind of silly. I agree. Python is a very dumb language. Screwed up the math. This looks cool. Can I ask how to play with the repo? Any requirement for running the project? Like only available on Linux? It should work on Mac OS technically. We have people that use it. There are a couple additional setup things that are slightly annoying. It will also work on WSL if you're on Windows, which is why we don't bother with native Windows, because you just have WSL available. And you can see all this stuff at puffer.ai. It's all open source. You can star the GitHub to help us out. It's free. If you want to get involved with dev or you need help, Discord's right here. Do star the puffer. Puffers eat stars. 2235 stars on the puffer. Not bad. What did I break here that's making this not learn? On Windows, we'll check it out, start it. Thank you very much. Probably update the Twitch descriptions. Match the ones. Any platforms. Yeah, so for some reason this is just not optimizing. So I'm guessing I just did something really dumb with the math here. Let me look at it for a second. Distance reward is negative. Yeah, they don't know what they're doing at all. So the signal's wrong somehow. Compute reward from reset agent. Let me make sure this is not the thing somehow. We're very close to having this, I think, fully solved. I can't imagine it's very difficult to get the last little bit of reward out of here. It's like, it's either the reward slightly off, or The agent can't quite see what it's doing, is my guess. Almost always the bug. Okay, so this is still not training. So this must mean I screwed something up, yeah? Not possible, what? What, aging? That's pretty obviously possible, right? What did I break here, man? Last collision reward times last target reward, right? Here, we'll do it this way. To rule this out. Oh, is it just a scaling issue? Yeah, I think it's just a scaling issue. Hang on. So let's do this. And let's like rebuild, and then if this works, then it's just straight up a scaling issue, and we can fix that pretty easily. Okay, it's straight up a scaling bug. All right, so if we clamp distance, we clamp distance to be one minus the distance. Oh, you don't get any reward then. Yeah, so that's the bug. You don't get any reward for getting closer to it until yeah, you just don't get any reward at all for getting closer to it until you're within 1 unit. Okay. So how do we fix this bug, huh? Can we just scale up the reward or whatever? So like another way to do this would be, so 1 minus distance divide by max distance. We just do like 10x this. Usually constant factors on reward don't help a ton, but we'll see. I just want to see what this does. Oh, this is interesting. I've actually started studying quantum lately. I've not gotten to all these different types of particles yet. I guess it's more particle physics. No, still quantum. Okay, so this is learning. I think this is learning worse than before, though. Yeah. I'm going to try this again with the normal scale to see how much of a difference that makes. Still run eval even though I fat fingered that. Okay, so they go to their targets, but they like do this crazy thing. Interesting. Let's see if we see that same thing on a much smaller scale. And while this trains, I'm actually going to see if I can intuit what I did wrong with the reward function. One minus the distance divided by the maximum possible distance, right? So whether this can actually be 0 or not is questionable, but it can... whether or not this can be... Oh, hang on, wait. Distance is... Word is... Okay, whether or not this can be 0 is questionable, but it can always be 1. If you're exactly on the target, you get 1. Swooping back and forth behavior. Just like over eager to get the reward or something. I could add a velocity matching reward technically. I mean, this is almost perfect, according to this thing. So, like, why... What's making it not be actually perfect? I mean, you can't... The thing is, they start off the way they start off. Oh no, they start off at the target, so it can actually literally be perfect, huh? You can kind of see that they're, like, slightly off target, I guess. Like, they're not perfectly on the sphere. Very close. A heck of a lot better than before. But they're not exactly on the target. Do we have any ideas on this? Well, first of all, there's very little There's very, very little additional reward for them to gain. Over 1,000 steps, they can gain an additional 14 reward. Or 14 score. Penalize non-zero. I could do that. I shouldn't have to, though. You would agree, right? If they can see their target, and they're getting rewarded, the way that I have the reward defined should be robust as well, in the sense that, like, you're getting rewarded for moving towards the target. So, like, you get 0 reward if you're, like, hanging out next to a target. It's not like you're collecting more reward there than if you're farther away. You get rewards specifically for going towards the target. It should be very easy to learn something like this. It's not like one of those scenarios where it's 0.99 reward here and 0.991 reward here and it can't tell the difference. There's 14 reward to gain. What are our hypers for this? Let me try something. Just for the sake of it, real quick. This looks kind of similar to those robotics problems that should be really easy time horizon wise. Isn't it kind of weird that gamma was set, like, the optimized gamma was set that high? It's weird, isn't it? Like, this should not require super long horizons. They also have very noisy corrections. Yeah, so the question's why? See, this is, like, way worse. It's learning nice and stably. I already have a very high learning rate, though. Am I just going to set this to 0.05 and hope it works? Is that really the play right now? Like, what is this? Why does it learn this slowly, yeah? Some weird, like, co-optimization thing going on. Because neither of these make sense to me. Like, why would you need a gamma of 0.997? Okay, I mean, we can hypothesize. We can try this. We can hypothesize maybe it's capacity. Bigger network. We looked at the policy, what the policy outputs when the agent spawns on the goal. I mean, that is what happens every time I render it, right? Like, they drift off a little bit. Or some of them drift off a little bit and can't quite find their target. Let me run this capacity experiment real quick. And then if this doesn't do any better, we will go back to drawing board. It's like so close as well. It's 99% of the way there. If the bigger network actually does worse, it's also possible this is just like a tiny hyperparameter failure, right? The policy is also stochastic, but it should be self-correcting in a sense. The policy, it should really be self-correcting. Like, even if the policy is a little bit noisy, it shouldn't, like, hover next to the target. Go to the target and, like, dip this way a little bit and then go back. It should be a lot more responsive. This is actually slightly better. It seems. Is it? Might be the same. No, it's the same. Basically the same. This is what the policy looks like. We're kind of splitting hairs at this point. Like, it's almost perfect. Let's leave it like this. Let me see what happens if we do the full train set. This will now train on all the tasks jointly. Okay, we get a slightly messier curve. Hello, welcome. Let me get rid of that other bot over there. Cool. So, we'll see what this result corresponds to. Possible this just works. Also possible needs to be trained for longer. I don't know, lots of possibilities technically. I guess it should be a little bit concerning that I believe this was the curve from before and we're not doing like hugely better. Okay, so like this orbit task. Oh no, I mean, this is decent. Hover. We can see actually based on this that the hover performance is like not quite as good as it was previously. And there are a few drones that can't find their target. Okay, there's this follow target. Pretty decent. Got the cube task where they have to spread out and make a cube. Getting to be decent. Okay, no, this is pretty good, right? Like, they're the last two drones filtering in. It takes them a second, but that is a perfect drone cube. Okay, I mean, this is like a drone Congo, yeah? The flag? How's our flag look? There are a couple of them that are like having difficulty finding their target. Pretty sick, yeah. I'm trying to think how do we get this to like they need to form the flag faster. Like you see actually when one of them gets in the way, they try to like avoid crashing. What if we just train for the flag task real quick? I just want to see like single task. Because it's also just it's possible like we just need to train for longer with all these tasks, right? Flag task should be not that hard. The cool thing about this is it's not like technically right, you can just program drones to go to a specific spot. That's really easy. But like if you watch how these were filling in the flag, when one of them like bumped up, the others would try to get out of the way. Pretty cool, right? Like, don't crash into me. Ten. I actually don't know what the thing is. I don't know what the best score is possible on these. I only know an upper bound. So if you were to teleport to the target and stay there, it's going to be 1024 or a perf of 1. Same thing. I wonder if we could design drones that, like, don't really mind that much if they bonk into each other a little bit. I could probably do that. You just have to put the rotors in, like, a mesh ball thing and it would be fine. Hey, Jub Jub. On 4th of July. I have a 4th of July thematically appropriate project, you see. There you go. That's good enough to post, right? Yeah, that's good enough to post, absolutely. No spangled stars? You can't do it at this resolution. Alright, I only have, it's 64 drones. I could train it with more drones, but it starts to become messier. So I wanted to do something. I always do stuff with like 1,000 agents. I wanted to do something more moderate. Increase number of drones. 256. See, I could. It's going to mess with some stuff, though. So the way I code these environments, when I do super quick prototypes, right, I do, like, quadratic checking. So, like, I could do it. It's just, it's going to be slower and more annoying. That is what puffers excel at. The thing is, I don't even know if it's going to be cooler. Like, I actually don't even think it will be, because the thing is, when you have a ton of agents, they basically just become points. Like, I downsampled this demo on the site. I also want to have this thing posted before it gets too late in the day, because it is the 4th. Like, here, I downsampled this thing, and you can't really tell the difference. Like, I tried to do an even bigger version of this, and it's like, you literally can't see the puffers at some point. We'll do this for now. Because I want to also... There's other stuff I can work on with you guys today. Yeah. This is also, like, partially an ad for Puffer in some sense. Better soon, yeah. Why is this stuff so slow? Oh my gosh. There's something wrong with the file browser, I think, on Ubuntu. You're doing some crazy stuff. Can I be in your team? I'm a full stack dev. Love to connect with you if possible. So here's the thing with the way that Puffer works. All this stuff is open source. It's all freely available. We have a whole bunch of open source contributors who build stuff, and we train them for free. But full-time positions don't really happen. We do have contracting stuff, but basically that is dependent on specific clients. You know, if you start building some stuff and say, hey, this would be applicable to a specific area, and I think that we could do something here, then that's when we start pulling people for jobs on that. We don't just do like, you know, core development full-time positions or anything like that. And the reason for that is it's a bootstrapped company. There's not VC funding for this, so I try to keep it to make it sustainable. It's pretty much like to get payment out, there must be contracts in, if that makes sense, at least for the time being. This thing is, I don't know what it is with the file browser that does that. The file browser lags everything. Stars. I thought of it. It's not gonna look right. I think this is fine for demo. I don't think it's gonna make a huge difference. Nah, this is good. Camera and fly backwards. Yeah, there are a lot of things we could do. I just wanted to have us a demo done. Let me send this to Spencer. He'll get a kick out of it. All right, let's train up a... Here's what we're going to do real quick. Rebuild. I want to train... I think we can just kind of leave this, and I can, like, put this on another machine to train a bigger policy. Yeah, I'm happy with this. Okay, so this is available now if you guys want to play with it. We'll see how that post does. One problem with posting on holidays is even if the stuff is cool, people are kind of out doing barbecues. Deliver freedom. It is Freedom Day. Let me actually just put this into the one of these chats. Holy, why is everything so laggy today, man? Fireworks Day. I'm getting kind of confused why this is. Not memory. Yeah, I don't know why that's so laggy. I guess they're all fighting over the same cores or something, because this is a 16-core processor. OBS is using 2 cores, Chrome is using like 2 or 3 cores, and that's it. The fact that Chrome is using like 3 cores is kind of pathetic, to be fair. Crap browser. You've been targeted. Pretty stupid to target open source work, but sure. Alright. I'm gonna use the restroom real quick, and then we'll see what we do next. There are several options for other things I can work on today. I'd suppose I could do robotic stuff, fight the robots a little bit. I could work a little bit on our quick start guide, like the new RL for beginners guide. I was planning on doing some of that tomorrow, but if you all want, I can work on it a little bit today and take feedback and suggestions. It's going to be a little less interactive in the sense that, like, I have to focus to write paragraphs and stuff, but I will take suggestions live. So probably between that, robotics, and messing with the tactics environment, like the 2 armies. Kind of janky, but mostly works environment. I'll be right back. Y'all can vote on that. See if I'm out of coffee, because that might pose a problem. There was more coffee. I did forget the daily deadlift though. All right, most people want me to work on the beginner's guide, which is actually cool by me because I've kind of had like 3 days worth of screwing with fiddly experiments in a row, and it gets old. It gets old. Do we have 2 trillion likes and a bunch of inbound yet? Oh, Himanshu, yeah, you can just join. You can literally just join the Discord, like go through our starter material and start building stuff with us. There's not like a formal requirement at all. It's self-selecting, right? It's just the people who actually stick around long enough to learn and to build good things are the ones who like push forward the research and who get promoted and all that type of stuff. And I've pulled a couple people for financially valid like business side contracts and stuff. I don't put that as a promise. It really depends on whether your stuff's directly applicable to a contract. But it is something that's out there. Oh, okay, cool. 10 and 9 minutes. We'll see how that does. All right, so here's the beginner's guide that I started. I will give you the parameters for this. Oh, I just realized that that's probably what's eating all my bandwidth, is that I have the stream preview on in 2 separate places. Oh yeah, that's immediately better. Here is the idea behind the guide here. One, it's going to be an ultra opinionated guide. It's not going to be me covering the stuff in Sutton and Bardo, just like slightly different. It's not going to be like any of the existing resources, but slightly different. It's going to be something completely different. It's going to be, the only thing it will be similar to is my quick start guide, because that is the other piece I have on the same topic, but very much expanded on with a whole bunch of additional things, and it's going to go deeper in a lot of areas as well. That is the goal. Additionally, it will have two main sections. The first section is going to be for people who have competent programming and AI experience. So this is like, if you have knowledge at the level of CS231N, and you are a competent programmer, where my bar for that is admittedly quite high, but if you are a competent programmer and have knowledge at the level of CS231N, you're ready to learn all this stuff. And that's mostly the level of things presented in the Quick Start Guide, but I'm going to be able to reorganize stuff quite a bit, because there's also going to be a section that's, what if I don't know anything? Or what if I'm somewhere between I don't know anything and I don't have knowledge at the level of 231N and competent programming, yada yada. So that's going to contain my advice for how to get good at programming in general, and my advice for how to learn AI basics in general. I actually think that of those two tasks, being a competent programmer is way harder. Like, literally, of everything that I have learned, everything in my toolkit, right, of all the stuff I do in my job here, writing good code is the hardest part of that. And the people who say otherwise, it's just that, like, you know, their bar is down here, my bar is up here, and there's actually a practical difference between being this good and being this good. Because being this good, you're basically a problems engineer, you just make problems for everybody, and being this good, you solve everybody else's problems. Drop it in chat, please. There's no place for me to drop the article in chat because this is a in-progress article. So what you're seeing is what is currently there, and I'm going to be writing on it live. Do you think great programming skills are gifted or earned? Absolutely 100% earned. Okay? If you saw the things that I wrote in the first literally 5 years of programming, this would not be a question. I was not a gifted programmer at all. Arguably, you could say I was somewhat gifted in, like, the intuition of how I view problems in research and AI and stuff. Like, that was something that I got to be pretty good at relatively quickly. And, yeah, like, I have some spots where there's definitely, I have advantages, but programming ain't one of them. That was blood, sweat, and tears. Okay, we'll go through the intro section. I'll read through this. You can give me your initial thoughts. And then I think we'll start on this portion of the guide. Actually, do I want to do it that way? I think I want to just start with the actual content, because this is mostly just like a snarky introduction that frames the article. But does this make sense, though, structurally, right? First of all, this is going to be a very, very different guide from anything else in the field. It's kind of the same thing as when you come to Pufferlib expecting something that looks like the rest of RL and it doesn't. The guide is going to be the same thing, so it's not going to cover stuff in the same order or anything like that. The fact that it has the 2 starting points, I actually give you this little litmus test. If you can implement an LSTM in like 100 lines or less than 100 lines, you are competent. Otherwise, start at square 0. And then there's a little bit of a thing here for like new viewers and new people because it's a little bit broader. I might change this up a little bit. We'll see. Okay, so this is just stuff from viewers, like stuff that people asked me to include. Vibe coding is now the trend these days. Person knows the basics. Can it write a good program these days? Does it matter? Be a master? Yes, it does. If you're just typing shit into LLMs and pasting that, you are garbage. You know absolutely nothing, and you should not touch any problem ever because you're going to create more problems than solutions. Just straight up. Like, being a good programmer is the basis of literally everything. It's actually pretty much the only thing I will flame people for in Puffer. Like, you know, if you're new in learning RL, you're going to ask a bunch of questions that don't make sense. You're going to make a bunch of mistakes. You're going to cause bugs that cost me time. All of that is fine. The only thing that I will go off on people for the most part, is, like, just making a mess of things with an LLM because they were too lazy to actually learn the thing. I mean, I could literally do the same thing for writing, right? Why don't I just generate this article with an LLM, right? Writing is easier than programming. Definitely is easier than programming. It is an education tool. It is, but guess what? It breaks even in that because, like, as soon as you go like any amount of depth into a topic, it just lies to you half the time. I tried using it to learn quantum mechanics the other day, like to ask specific questions about a quantum mechanics course that I was going through, and it just made stuff up and wasted like 4 hours of my time and drove me nuts with like insane quantum things that aren't actually true. LM is good. First time we have effective didactic education at scale. Education is instruction earlier. Doubts are cleared. Basic stuff, it's good. Shouldn't use LM to have your doubts cleared on any subject at all. Well, it's... The thing is, this is an area where if they were better, it would actually be useful. Because basically, there are definitely questions that you can ask, right? That, like, anybody who has any decent understanding of a topic will be able to answer. but you're not going to be able to ask that exact question and like find an answer to that without talking to a person in that space. So LLMs are kind of getting to this point that you can do that on basic things. It's just as soon as there's any amount of depth, it all goes out the window. Like, you can probably ask an LLM about different integration methods if you're learning calculus and be fine. What do you think will these LLMs reach someday when mastering programming won't be necessary? It's AI complete. So if the LLM is a perfect programmer, then all problems are probably solved. That is my opinion. If an AI can just output arbitrary programs, then AI is solved, and we will live in a crazy sci-fi world. Because if you give me 10,000 years at my current skill level, if you give me 10,000 years to just like code on things to make crazy tech happen, I will make crazy tech happen. The problem is I don't have 10,000 years, at least unless we make some pretty good advancements here, right? It takes a minimum of 10 years to get good, and then you've got somewhere between 20 and 50 years of a career, and that's it. So it's tough. Protein folding's just around the corner. Custom non-aging for all pufferlib people. Man, I hope so. I don't know if protein folding alone doesn't solve that, though. Not as far as I'm aware. I don't know. Can I just, like, drink a flask of microbots that, like, circulate through and repair everything? That would be pretty good. Okay, so this is the framing. It's intentionally put very aggressively because this is important, and it has to be. I think these are points that have to be made bluntly. In fact, I literally already have this in the article. And this is for people who have some programming experience. Fighting death is like fighting evolution. Not a fight you want to win? Who says? I will gladly fight evolution. It's a really stupid, inefficient process just at massive parallel scale. So it's still crucial to sharpen programming skills even for a researcher. It's the most important skill set that I have. How do you balance between doing research and coding? I mean, what am I doing during the vast majority of my time as a researcher? I'm writing code. You do research, like, you read papers, you synthesize ideas, but for the most part, you write code. It is the mechanism by which research is done. Joseph versus evolution? Absolutely. Robust beats efficiency on long time horizons? I mean, do you believe that evolution is literally the most optimal process by which anything can happen? the most robust. It's just the process that we happen to know, right? Not really robust either. Creates all kinds of stupid problems. Never go backwards. Well, I mean, if you want to get like pessimistic here, if we all nuke ourselves out of existence before we solve AI, that's gonna make it go pretty far backwards. Anyways, let's get to actual work here. So, I wanted to write like a basic how to think about programming. Survived a fair portion of cosmic. We literally have one example of it here on one planet. Okay, so the point I want to make here, something of programming as a craft. That's a nice little intro. I think that's a nice little intro. I think we get very concrete from here very quickly. Fast simulations. Making simulations and integrating with Puffer. I will cover Pufferlib, and I will directly cover Pufferlib in this guide as well. This right now, I'm writing the beginner section because people have asked me for it. So this is going to cover my general advice to new programmers first on how to learn, and then it is going to cover. It is also going to cover my general advice to new AI people on how to learn AI. Not even general, very specific. Let's not do general. As specific as possible. Couch instead of cafe. Cafe works as well. In fact, even better. Used for new programmer. Exploration versus explanation. Exploitation. That's an RL thing. I'm not. That's like a learning in general thing. I think mastering DSA is mastering programming. Is this correct? Absolutely not. In fact, many of the people that will like ace all the DSA interviews for all the because companies just use them relentlessly are absolutely terrible programmers who I never want to touch any of my code ever. Exploration versus explanation. I don't know what you mean about that. I haven't heard that before. There's really not anything to memorize is the thing. Because the thing is the way that I write stuff, I should explain this, but like it really is a very small set of tools to learn. A very small set of tools. What's the judging criteria then? Well, in Pufferlib, it's just if you make good stuff, right? I can roughly, I'm not going to out of respect, right? But I can roughly rank the competency of everybody involved with Pufferlib based on the stuff that they have built. Why measure some synthetic test, right, when I have real results? These. Okay, Git is you need to use Git, which is 3 commands. Docker's kind of a pain, but it also doesn't take any time at all to learn once you know what you're doing. Kubernetes can fuck off. And like basic terminal usage and stuff is just things that you pick up over time. But like even if you watch the way that I do stuff when I'm doing things, if you just go count the total number of commands or tools or things I use, it is very small. Complex workflows can twist one's mind. Don't use complex workflows. That's it. I don't. You don't have to. Self-imposed. Yeah, He-Man. There's literally we've had people come to Pufferlib and like submit really bad code that worked but was really bad, and then like gotten feedback, improved, and who are now at the level of, well, actually, I would say on just programming alone, way better than the level of other PhDs in my field. So it's a lot of this stuff is very learnable. Now, the AI perspective, right, that takes a little longer, but I will cover that as well. Team has shitty Git etiquettes. Yeah, so that's not, but that's not like a how to learn to program, right? That's how to learn, that's how to deal with stupid people. And there's no guide for dealing with stupid people. It's just you suffer. See this sentence here. It's really that simple. Like, if you take me with all the stuff that I build and you put me in a big team working on some problem, right? Like, I'm not, like, there are very many projects that I wouldn't be able to contribute anything because of what a mess people made. Like, it's literally to the point that very, very often the best solution is to just scrap the whole thing and rewrite it. And that's done very often. If you have 200,000 lines of code for a problem that should take 10,000, right? What the hell am I supposed to do? Doesn't matter if you're a genius, you're screwed. Oh yeah, also how's this article doing? Or the this thing doing? Doing stuff. All right. Is it a shade on a Rust rewrite of core utils? I personally do not enjoy Rust in any way, shape, or form. I think it's like fine for things where you're really concerned about memory management bugs for some specific reason, like some like embedded systems dev. It could make sense. But if you're not, there are just a number of things in that language I think are very stupid and overly constraining. Important to explain why Python sucks. Yeah, actually, I'm trying to think. How do I want to frame this? A new dev is not going to appreciate the explanation is the thing. But like the thing is it's more than just that, right? So it's more than just interpreted versus compiled. That's not the main thing that's screwy with it. That's like the performance reason that's screwy with it, right? Actually, I can just say that. You know what? Let's just make this not a list. Actually, not needs to be succinct. Why old devs hate the language? File Python code efficiency. Dub it in Python code. Go to a C. Okay, so the problem, right, is that writing bindings, Python to C bindings is hell. It sucks. It's not fun. It's actually the reason why I liked Cython for a little bit, even though Cython's a total mess as well, is because, at least in Cython, once your Cython builds, you can literally just mix Python code and C code, like alternating with no problems and no extra bindings and build systems and crap. Unfortunately, Cython has its own problems, because if that actually worked, it would be fantastic. through this. A blog on the Python thing. Like to read more? I don't think I did. I might have written something about it a while ago. So here's the thing. So Python, it is a domain-specific language that is a mix of Python and C. You can inline something that is, I mean, you can directly call stuff from the C standard libraries and malloc and things like that. It's basically you can write C in Python with almost identical syntax, but you can also write Python, and then variables that are typed get declared as typed variables and they get compiled efficiently, and variables that are not just don't. So it's a really nice way to let you mix and match C and Python. The problem is that whenever you compile Python, it basically takes your short little source file and turns it into a minimum of a 30,000 line unreadable C file. And then the compiler also has a bunch of weird, like, annoying error reporting and bugs that it doesn't give you as nice errors, say, as C. The debugging experience is not as good as in C. So what ends up happening is I end up just, like, preferring to do the entire thing in C instead of having to deal with the Python quirks. It could be really good, mind you. Like, Python could be something that would be really good, but it's just not quite there. Working on 4 to 7 integer multiplication problem when I realized MLPs or any neural nets activations can't do basic multiplications. Yes, well, they kind of like have to embed them into the space in a weird way. It's not a natural operation. You can technically write activations, right, that do like dot products of embeddings. Like you can dot product layers, or you can like pointwise multiply layers. You can also look into things like CPPNs, which probably are a good way of representing functions. The thing is, they're incredibly slow. Really succinct. The drop will try to be back more frequent. Thank you. There's an architecture I can learn that and not introduce multiplication terms. Not introduce. I mean, that's pretty much what they do, though, right? It's like if you have multiple different encoding layers, they add pointwise multiplications. It's kind of cheap, right? Because you are sort of cheesing the operation in a sense. But yeah, I've done the same thing before, and it's pretty annoying to learn things like that. It's like a really weird decision bound. Why not pass per vector? Well, you don't want to do it over the input, right? You would do it over an embedding. I mean, one good test of this, right, would be like if your network can learn both multiplication and addition, or like any like like you could do something like that, right? I don't think how to frame this. Turing machine M struck greater than 4 multiplication. The reward at the end of its computation and only if it's correct. Have you tried like training it on? Are you doing any sort of curriculum learning? Giving it like random length multiplications, seeing like what the length solve goes up over time. Mac OS CI failed with my last commit. God damn it. Max, man. You gotta be kidding me. Oh, that's so stupid. Mac specific compiler garbage. I'll fix that. It needs to be pound defined is all. Yeah, bet. Did you see the drone flag? It just needs to be pound defined. Flag. Very cool. Any? Nope. All spam. No client inbound. I'm trying to think how I can frame this. Problem length is random. That should be decent. Like, cool. And let me figure out how I want to frame this. know, for word shaping. Yeah, it could be architectural. It could be scaling. There are lots of things it could be. Could be data. It's very often data. What is an example of that? What will? Too much abstraction from Python? We want more granular control? Yeah, I don't want to get into the object-oriented versus procedural versus everything else, because it's just a mess. Um, but like pretty much, People just you end up writing 10 times too much code that's 1,000 times too slow. The crux of it. And it just happens all the time, even with experienced devs who should know better. It's the language itself pushes you towards that. Because Python wants you to write a class, and then it wants that class to interact with another class. Try to even make stuff that looks more like C-style code in Python. The language will fight you. And then once you have classes, you may as well have them wrapped with each other. It ends up piling more and more abstraction on itself by design. Very, very hard to not just completely break your knees on the abstraction tree and trip over and fall. I don't know. I'm trying to think what I can even give people as like a quick recommendation. Some of the AI models, very little progress in live benchmarking, say that they plateau. No, I don't think they're plateaued. And the advice I'm giving here is relevant regardless. Raylib. else? What are like the common like things that Python does that are obnoxious? I mean, Python has a ton of built-ins, right? Comma tuple thing. Ah, that's like a specific like syntax thing. I mostly don't want people to get hung up on like all the crap that's in Python. Most of the ML libraries are easy to implement using Python. What do you mean to implement? ML libraries are not implemented in Python. Up here. There's some heavy tasks that can be done using libraries. A lot of libraries Python does. That's just bindings. Like, yeah, there are bindings. Not that they're easy to implement using Python. None of the core logic is in Python at all. You can't just use libraries either. Like, a lot of the engines, they have their own core. They've got their own kernels and stuff. They have their own low-level code that's not in Python, not just library calls. You end up having to do both. I think this is good. Stars up, thank you. The environment still builds, right? Oh, undef. Yeah, you can do that. Thing. Constants in C bother me. Played chess. Local eval. Yeah, the chess project, I've been like watching some chess stuff. I honestly think you could really make something good there. And like the thing is, self-play in chess should be really, really fast. At least if we figure out the action space shenanigans. You should be able to run self-play in chess at like 3 million steps per second. And then you can eval it against Stockfish or whatever separately. And you can get a really, really clear ELO evaluation. 1 second. I use the restroom 1 second. Right back. Welcome, potato. Typecast, or is it one word? Typecast. Yes. Self-play collapses at the moment, likely due to persisting environment bugs. How are you measuring whether it collapses, Bet? Because you're not going to get like a win rate, right? Versus self. It's always going to be 50%. Self-play, you're playing against yourself, so you're going to win half the games, right? Anything, a better thing to look at will be the length of a game if it gets to a reasonable thing. Draw equals 1. It depends. I would look at the episode length. Like, if you have ridiculously high episode lengths, they're probably just all spamming invalid moves. You should probably look at that, actually. If they can just learn to make valid moves, like, that's gonna already get you to a decent spot. Because once they're making valid moves, like, there are really not that many valid moves you can make in chess at any given time. Decreases steadily. That's decent. Like, what the thing is, once they're actually making once they're making valid moves, it should learn quite quickly. 20 moves per turn, yeah. So it's just it doesn't understand a valid versus invalid move. We might have to chat with some people on that, because like they did it this way for Mu Zero, I believe. Right? They did it that way for that paper. And I said, oh, okay, yeah, that sounds great. But I didn't realize that it's actually like 4,000 some odd dimensional. Kind of ridiculous. Probably also making stuff slow. Up in element 0. Yeah. What other things am I missing for like basic C here? Light and bit, yeah. They do it in such a weird, shitty order here. Can't even recommend a course. Yeah, I'm gonna cover that next. Bye. Have fun. Yeah, see ya, Bet. Enjoy the 4th. Happy 4th of July. Okay, I gotta kill a fly. This thing's gonna drive me insane. Go. Flies that don't leave you alone. Water here. Build a fly turret. Yeah, drive me insane. Got him. I think I got him. Those things. What tools do we suggest here? Good, capital. I changed it from grok to super grok. That's funny. The top. get right is the main thing. Had to drop out for a bit. How's progress going? Still on this like super basics guide. Almost done with this, I think. Okay. Uh, Let me think. What else do I want to put in this? Oh, it's 4:24. I think I've done a decent job of this. Are there any newer programmers around here that have questions and things that perhaps I have not addressed yet? How many tips do I have? One, two, three, 4, 5, 6, 7, 8. Could possibly do a top 10. I'll think about it a little bit, but if there are any relatively newer programmers, and let's qualify that by like, if the way that I'm writing code that you've seen in my day to day, if anything is like foreign or strange, you have questions, now is a great time to ask. I will include things in here. Here's a restroom real quick. No questions. Well, I can give a list of things to avoid. What is my list of things I hate? What are my list of things that I hate? Let me think. Anybody have crap stuff I'm forgetting about? Config systems, right? Package managers? What, you mean like Snap? You gotta know like your distro's built in like apt or whatever, yeah? I already included that though. What? Python package managers? Oh yeah. I'm gonna include, I think that the last bullet will be things that I like. UV is not going at the start of this, but it will be in there. I'm not gonna put like the framework on here. That's not gonna like tell anybody anything. Let me finish this thing first. What are the other things I don't want to steer people away from? Fancy CI. Oh yeah. Yeah. What tools do I don't really use that much stuff, right? Bash is in there. Well, mostly. UV is definitely. I really don't use that much stuff. Like, at all. Oh. My puffer's fast, exactly. Not really that many things I can suggest other, like, I don't use anything. Let's see, is there anything else here from this list that's missing? put this up here. Important. Add ricing into there. Trying Muon Optimizer for the first time. What is it that about it that you like? That it solves everything freaking instantly and is a generational leap over Atom in literally all of our tests. Just that. Implementing things from scratch, perhaps? Isn't RL model architecture thin, though? Yes? It is. Why would that matter? Which how are we doing here? Dang. Crash is right here. Fortunate. We do still have some bugs. That is still soda. We'll have to see if I can resume that. That's soda in half the time as well, so that literally cuts the train time in half for that same score. Treat hidden layers differently. Yeah. I mean, we have empirical data that it's better, right? Wrong case for Muon. 5 puffer, exactly. Just in puffer lib, it's our default. Just use it. Kind of want to go fix the experiment real quick. This is learning rate. Make sure this runs. Yeah, it got a nan. Weird. I think I can actually put this in with my main like AI stuff. But I thought of one other thing. Eh. Not this way. All right, I think these are like this is like a pretty good. Thousand-ish words. Like a decent length thing, I believe. This is actually ironically a lot easier than programming. This one is going to be shorter. It's literally easier to learn. If you already are a good programmer, it's literally easier to learn AI than it is to learn how to program. that true? I think that's true. Yeah, I think that's true. Did I take this my freshman year or my sophomore year? I took it my freshman year, didn't I? I don't remember. No, I took it my freshman year. I would have had to have. No, sophomore year. Yeah, it was my sophomore year. Bye. Here. Just delete this. Hang on, let me go check on what this is. Okay. Told not to work so much on the holidays. Little do you know that I consider this barely working. Well, I mean, I can only go so far back, right? If you haven't seen any calculus, it's like there are some prerequisites. Yeah, I mean, that's gotta be. Because the thing is, otherwise, you're not going to be able to learn ML because you just won't be familiar enough with even the notation to be able to read any research papers, right? So yeah, how to learn ML from scratch doesn't mean like you're an infant toddler, right? I've covered I've covered programming because it's a topic that's confusing and a lot of people think they know how to program but suck at it. ML is usually like people come in either, oh yeah, I have some math, or like I know some programming or whatever. Where do I get started? I think this is a good entry point. If you're asking for like from before this, there's some things you just need to figure out. Like, how do I learn? You do not need my advice on how to learn calculus. All right, it's like perfectly well covered. Is there anything else I suggest before papers? Not really. I think it's you're out of courses at this point, right? Actually, I'm going to save this. Hey man, good evening. I'm here with another question today. How do you do profiling to identify PyTorch indexing overheads? Couple ways to do that. One, PyTorch profiler. Pain in the ass because it returns you these massive graphs of every single operation, and they're kind of hard to read. They are sometimes useful, but often massively overkill. Much, much, much easier way is to do torch.cuda.synchronize, and then run your code, and then torch.cuda.synchronize, and just time that block. And then you can time that across different versions of code, indexing, not indexing, like what if I index with a slice, what if I don't, and you can very, very quickly time stuff out like that. The pufferlib trainer has a bunch of different blocks, like types of code that are all grouped together, just essentially using 20 lines of code that just does that. And at times, like the total amount of time spent in the forward passive evaluation, in the environment, in miscellaneous overhead, and it just shows me in that little dashboard all the different places that compute is being spent. So at a glance, I can know exactly what is the bottleneck. That is my main recommendation. Take a look at the profiler and the dashboard that I've built in pufferlib. A heck of a lot easier for most things. Now, if you're getting down to like timing individual layers and kernels and stuff, then you got to go to the PyTorch profiler. But for general usage, the thing I've suggested is pretty dang good. Anything else? Last paragraph you wrote is literally what I'm believing about the majority of researchers. Yeah, you see, this is like, I'm trying to provide this information because it's one thing to like discover this on your own slowly, and it's another to just like be told this by somebody that you have some respect and trust for. Like, this is literally the way it works. Now, let's see. Sections overlay. I can run bazillions of other baselines, but I have 8 GPUs max at the same time. Bye. Yeah. Dude, I didn't even have 8. I didn't even have 8. I literally didn't use any of MIT's hardware for basically my entire PhD because the cluster was such a mess. I like bought a bit of my own hardware and that was it. Nowadays, everyone's running after big breakthrough models and papers. They just randomly bump into a good run, make their full research life on top of that. Pretty much. We appreciate small scope and simple methods over, yeah, we created an alternate universe. Exactly. Robotics evals worse. Numbers, real robots mean nothing. No way. Yeah. Yeah, it's real bad. Pretty good. I'm trying to think what other. I have like a list of things, I guess, in ML. I can absolutely speak to like ways that papers. I should give some context on this. I think I should write a how science lies. You mean plenty of work? PS works on competition and pressure candidates. Yeah, it's like so. My lab was very good. I basically didn't have any pressure to do anything other than make sure I had like at least 3 papers by the time I was ready to graduate, which is really not that bad. But there are absolutely labs where they basically just force students to grind out like 4 papers per year. I don't even think I can speak to just how bullshit depressing and horrible trying to produce 4 papers a year is. It does depend a lot on your area because like there are areas where you can basically just reuse your same code repo and like make some changes and publish a whole new paper. Um, or like there are places where the implementations of the algorithms are actually quite short, so it's like not that bad. But just trying to like do creative, like hard science that requires thinking and experimentation and comparison and deep like research in such like a compressed time frame, and then having to produce a super boring dry manuscript out of it, um it's just horrible. It's not fun at all. Honestly, I think my best research cycle, so my best year for NeurIPS on my last year, um, I had 3 papers, and I spent like I think a total of 2 days writing all 3 papers. Because I just decided that instead of stressing over the thing and trying to like perfect it, I was just gonna write the dumbest, simplest, most bullshit thing I possibly could, because that's the way that writing is expected. And then those ones got in when papers that I actually spent weeks on trying to make actually good did not get accepted. So yeah. Checking competitions like Kaggle, reading top 10 winning solutions, formative than reading. Sometimes you want to be a little careful, though. You do want to be a little careful. Because, like, what happens a lot of the time with the Kaggle competitions is they get into this endless loop of feature engineering and shit. And, like, it works. And then eventually they just get steamrolled by, like, the new architecture or the new algorithm. Competitions in general are weird. Like, I organized a bunch of competitions. And, like, there are definitely some practical things that come out of it. But yeah, the competitions are definitely weird. Filter the solution, ensemble heavy stuff. Action masking. Yeah, so and action masking is pretty legitimate. It's tough because, like, actually a lot of the winners in the competition just kind of scaled the crap out of it. Like the Neural MMO 2 competition, it was kind of like they scaled the crap out of it. No, not Neural MMO 2. It was the one before that. This Neural MMO 2 competition, actually, that didn't get well, I can tell that story. So the reason that the Neural MMO 2 competition, the one before I graduated, uh, got like an eighth of the participation of the previous ones, even though it was like way better by every metric, is yeah, we had two or three sponsors. Yeah, three sponsors, and all of them screwed me. So I ended up having to personally pay the prize money for that. It caused, like, basically a bunch of people promised shit and then they pulled out, and after they'd already committed it and we'd announced it. So that caused me like a full summer's worth of unpaid work and a whole bunch of shit with the open source community that just wasn't fun for anybody. And at the end of the day, we didn't have the promotion, so stuff just didn't get advertised well. It was a whole nightmare. So I think the results for that competition should have been way better. And I think we would have seen something a little bit more interesting than the previous one. But yeah, these are the things that happen in science, right? It's not a pure discipline. It's still people doing shit. Yeah. It's still people doing shit. And people kind of suck. Had nothing to do with and I want to make this clear, had nothing to do with my advisor or my lab at all. He literally didn't even know that this stuff was happening, and he couldn't have done anything if I'd told him. So yeah. And this type of stuff is, like, stuff of this magnitude isn't even, like, super uncommon, frankly. PhD is long, you're gonna deal with some shit. Frankly, it's probably the reason that, you can criticize my work and that's fine. I get real pissed when people criticize my motives, though. Because I've proven my motives over many, many years. Oh, it's 5:53. So I gotta go for dinner in just a minute here, folks. I will finish this. I think I'm gonna write on this tomorrow, though, during the day. Because I think that this will be really good. If I can, like, actually make some good progress on this, I think that an article like this could do very well. I think people will be, like, this could be helpful for a ton of people. And hopefully, we'll get a bunch of new contributors out of this as well. I don't want to spend, like, a week writing just an article, but a few days actually, like, kind of between the other things I'm doing is pretty good. I think I'm happy with that. So, for the folks that have been here, thank you for your interest. All my research is free and open source. Find all of my stuff at puffer.ai. If you want to help me out for free, literally free, in 5 seconds, start the repo. It really, really helps. Like, the more stars this has, the more people Puffer gets recommended to, the more people see Pufferlib. It just helps. And if you want to get involved with research, the Discord link, discord.gg/puffer. There's no requirement to get involved with any of this. And pretty much all the contributors are just people who've showed up and thought that this looked like cool work and tried to learn this stuff. Other than that, you can follow me on X for more, and I will be back likely first thing in the morning. So thank you, and enjoy the 4th of July.